Good morning. I'm Dr. Prashanth. I'll be the presenter for this session, and I'll be talking about multi-threaded programming. If you recall, we have discussed about different computing environments in one of the previous classes. These are the three computing environments we have discussed about: uniprocessor environment, multiprocessor environment, and multi-core processor based computing environment. Now, I have put the picture of the motherboards here and here, and I have put the picture of the processor which is having two cores here. And if you look at this motherboard, there is one single slot to put the CPU, which means that you can put one single central processing unit in this motherboard. Okay, so there is a slot for inserting the ROM. This processor will have set of registers which includes program counter, which will help us to sequence the execution of instructions. And this is connected to main memory through the system bus. If you take this environment, you see here there are three different slots for accommodating the central processing units or processing elements. So therefore, here we can accommodate or insert three processing elements: CPU 1, CPU 2, and CPU 3. Each processor will have its own set of registers, and all of them shares a common main memory unit. So here symmetric multiprocessing is possible in the sense that these CPUs can run instructions independently and simultaneously. That means at any given point of time, three instructions could be executing in these three CPUs. Here, inside one single chip, we have two cores. You can have 2 to 8 cores on a chip, and each core works as a processor. What I'm trying to say is that each core is capable of executing the instructions independently. Okay, again, there will be a main memory in the system which is shared among all the cores which are present. So these are the three different computing environments that we discussed. I have given you a brief background of the same. Now you will understand why I discussed about uh, these computing environments in a while. Okay, now let me take a empty slide. Okay, I'll tell you. You know that what is our process? Process is nothing but a program which is in execution. Okay, so how does a process looks like when it is loaded onto the main memory? That is when it is compiled and loaded onto the main memory for execution. So this is how it looks like. Okay, so these are the instructions. These instructions are brought into the memory. How can we sequence the execution of instructions? Inside the CPU, there is a specific register called program counter or instruction pointer, which always holds the address of the next instruction that is to be brought into the CPU. Okay, from the main memory. In this case, if this happens to be the first instruction, this is brought into the program counter. So there can be a instruction queue for storing these instructions. So instructions are brought one after the other into this queue and executed in first come first serve manner. That is, this instruction is executed first, then the program counter is incremented, it points to the next instruction that is brought into the CPU and executed, and so on. Now if you see, there is a single thread of execution. Single, you can call it as a thread of execution. Okay, now this is a little bit of background to understand. If you are running this single process on the three different computing environments that we just discussed, now let's see um, what will be the issue. Okay, so let me take this slide. Now, as I told you, in a uniprocessor environment you will have one CPU, and in a multiprocessor environment you will have multiple CPUs. Okay, here in this case we have three CPUs. A multi-processor based computing environment, we have multiple cores present inside the processor. In this case we have two cores. I have named it as processing element 1 and processing element 2. So there can be more than two cores inside the processor. Okay, this is what we just discussed. Now let me explain the scenario of running this process P alone on these three different computing environments. What happens when you run the process P in this uniprocessor environment? See, the CPU, complete CPU is at the disposal of this process. So here in this case, either this process is running or this process is not running. When the process P is not running, the CPU is idle. Okay, otherwise the CPU is occupied. Whereas in this case, what happens if this process P is scheduled on this processor, that is CPU 1, CPU 2 and CPU 3 are going to remain idle. So these will remain idle because there is we have assumed that there is only one process in the system. Okay. Similarly, here suppose if this process is picked up by this core C2, then the C1 is going to remain idle. Okay. So the issue here is, though we have you know huge compute power here and here, we are underutilizing that compute power, or we are underutilizing the potential of the hardware. Okay, we have got the better computing capability, but then we are not utilizing it to the fullest extent. Now, how this problem can be solved? Okay, so let us look at mm, that. Let me clear this. Now, what I do, I take this process P and I divide this process P into subtasks, say T1, T2 and T3, and I write them as threads inside this process with the support of some thread library. So that means this thread T1 or T2 and T3 can run concurrently. Or independently. If they are not depending on each other. Okay, so now in this environment, uniprocessor environment, now one of these threads could be running at any given point of time. Okay, so if it is a time shared operating system, every thread will get some time slice to run. Okay, T1, T2 and T3. So thereby what happens is that the process P um, completes its execution faster. That means the execution time of process P comes down. When it comes to multiprocessor environment, you see T1, T2 and T3 can be run at the same time or simultaneously. So therefore, on this kind of a platform, the execution time of process P drastically comes down. Here also you can schedule two threads on these two different cores and they can run simultaneously. Since the operating system is time shared, T1 when T1 completes its time slice and T1 will run on this, or when T3 completes its time slice, T1 will run on this. So here also the execution time of the process P will drastically come down. So now we have solved the problem of efficiently utilizing the hardware, right? So how did we do that? So solution uh, for efficient utilization of the hardware is what is known as multi-threaded programming, or creating the process, or you can create multiple threads inside the process, and these threads can run parallelly in case of multiprocessor environment and multi-core processor based computing environment, or they can run concurrently in case of a uniprocessor environment. Okay, so that's the significance or advantage of creating multiple threads inside the process. Okay, so all of them will have their own thread of execution. Now let us mm, see um, let us discuss a little more about these uh, threads. Let me take up this slide. So here if you see, when a process is created, um, text related to that process, this text is nothing but the set of instructions, okay, related to that process, and data associated with that, and if some files are required to read and write, all these are the part of the process which is running. Okay, and this process will also write something onto the register, and it will also get some space in the memory for storing the intermediate results. So this data structure can be called as a stack, and the contents of the register. If process pauses for some reason, so the contents of the registers and the contents present on the stack all are saved. Okay, so this kind of a process has got a single thread of execution. Whereas if you look at, this is single threaded process, and if you look at multi-threaded process here, the threads live in the address space of the process. Okay, so that means the threads, all the threads here, if you will see, there are three threads, okay, or three threads of execution. All of them share the code part, data part, and the files part, or any other resources allocated by the operating system to that particular process. But every thread has got its own you know um, set of registers, in the sense that when it is running, it might write something onto the registers which are saved. Okay, and every thread will get some space for stacking the intermediate uh, results or data that it can generate when it is running. Okay, now every thread will have a program counter associated. That means the thread will use the content of this program counter for sequencing the execution of instructions. So this is about multi-threaded process. This is the difference between a single threaded process and a multi-threaded process. So let me just give you a summary of whatever we have discussed so far, and I'll tell you the advantages of threads. Okay, so let me go to the next slide. Here I have summarized uh, the information about the thread. Thread can be defined as a basic unit of CPU utilization. A thread will have a thread ID. Like I said, thread will have a program counter, register set, and a stack. So because the thread lives in the address space of the process, thread can also be called as lightweight process, whereas an actual conventional process is a heavyweight process. Okay, so like I said, this thread shares the code section, data section, and other operating system resources such as open files of the process in which it lives in. Okay, there could be multiple threads attached to a process, and all of them share code section, data section, and other resources. So for example, let us say you are using a word processing software. There could be multiple, in this application there could be multiple threads for different purposes. For example, there could be a thread for displaying the graphics. There could be a thread for responding to the keystrokes from the user, and there could be a thread for performing the spelling, grammar checking in the background. So what happens is the program or the multi-thread application becomes highly responsive. We will look at the different advantages that we get when we use the concept of multi-threaded programming. Okay, so these are the advantages of threads. When you use threads, let's say you have created some um, 4 threads inside the process, user threads inside the process. Now let us assume that this T3 completes ahead of T1, T2 and T4, and whatever the output that it produces, T3 produces, can be quickly shown to the user. So such an application becomes highly responsive, right? And because all of them live in the address space of the process as we discussed, the context switching becomes very easy. Context switching is if there is one single CPU for the execution of the threads, then now you can remove one thread which is running from the CPU, and put another thread. For example, if T1 is running, you can remove this T1 and put T2. That is called as context switching. Context switching in the sense whatever you know T2 requires to run the contents of register and program counter, that are loaded onto the registers and program counter, and this T2 is made to run. Because all the threads are sharing code section, data section, and all other resources, operating system resources, so better resource sharing happens. Okay, effective utilization of the multiprocessor system. Yes, these threads can be run simultaneously. In a multiprocessor system, if you have multiple threads, you can run them simultaneously. Communication between the threads is easy because they share the address space of the process. So communication becomes simple. It can a part of the memory or the part of the address space can be used for writing the data which has to be communicated to some other thread, or the thread can read the data from this shared area. Obviously, when you have a multi-threaded application, you can complete or you can see to it that more number of processes are executed in the given unit time, which is nothing but the throughput. The throughput obviously increases. Okay, so these are the advantages of using the multi-threaded programming. Now, these threads can be handled by the operating system in a different way, and we call them as multi-threading models. Let's discuss about these multi-threading models, which are very popular. The first one is many to one. Okay, so these are the threads present inside the process created by the user, and you can call them as user threads. If operating system creates this kind of a thread for handling the threads, you can call it as a kernel thread or operating system thread. If you look at this model carefully, there are multiple threads and all of them are attached to one single kernel thread. So multiple user threads are handled by one kernel thread. I will leave it to you to find out which operating system uses this model for handling the user threads. If you see the mm, disadvantage in this case, you can call it as a disadvantage. Now suppose one of the user threads makes a system call. That means it is taking the help of the operating system, right? So the operating system busy in serving this thread, whereas if other threads wants to utilize the services of the operating system, they cannot do so because the operating system is already busy serving the request made by one of the threads. So that's the disadvantage with this many to one model. Okay, now let us look at the second model, which is also used in many of the operating system, that is one to one. Here you could have guessed by this time that every user thread that gets created will force the operating system to create a corresponding thread to handle them. So that means if this is thread 1, there is one thread, operating system thread, which is handling this thread 1. Similarly, if this is thread 2, there is one operating system thread which is handling this. So this kind of a model is called as one-to-one model. This model supports high level of parallelism. That means the problem that I discussed with the many to one model is now here solved. All the threads can make the system calls at once. Okay, and all of them would still run and they are not halted. So that's the advantage of this one-to-one model. Okay, now let us go to the next model and see the advantages and the disadvantages. The next model is many to one model. You can, if you look at it, you can easily guess what is happening here. Here, the user threads are mapped to multiple kernel threads, right? That means the T1 is tied to all these tied in the sense mapped to all these kernel threads, and T2 is also. So that means T1, T2, T3 user threads can take the services of any of these threads. So this is an interesting model. That is, if one of the kernel thread is blocked for some reason, or it is serving the request made by one of the user threads, the if it is let us say this thread is is trying to serve the request made by T1, and if now T2 makes a request, any of the kernel threads can uh, serve this request. Okay, that's the advantage of this model. So this way there are three common or popular models found in the operating systems to handle the user threads. Okay, so user threads creation, deletion of user threads is supported by several uh, thread libraries. I'll just show you what are the popular libraries which are available, thread libraries which are available. POSIX pthreads. At the end of this session, I'm going to show you, demonstrate to you one of the programs which I have created in C using pthread library. Okay, POSIX pthreads library. We have Win32 threads, which has a lot of applications to handle the threads, and we have Java threads. I'll not be discussing in detail about these in this video, but you can refer to uh, you know the videos which are available online, and if you want you can learn more about these thread libraries and how to use them in your applications. Okay, so let me now take you through one of the example applications that I have created, which will make things like creation of threads and how thread executes within the address space of the process, all these things very clear. Okay, so I have created a virtual machine and I have loaded Ubuntu on that. I have written a C program which is a non-threaded or single threaded program. I'm going to show you that. I've named it as thread 2. Okay, so if you see this, don't worry, I have included pthread.h, but I am not using thread concept here, so don't bother about this. I have used this UNI std to use this sleep function. Okay, If you look at it carefully, in the main there are two procedure calls, my turn and U turn. I've defined the procedures here. This is one procedure, and this is procedure P1, and this is procedure P2. Okay. What I'm doing is there is an infinite loop in both in process P1 and process P2. Okay, so these loops will run forever. Process P1 is going to print my turn, and process P2 is going to print your turn. When I execute this program, what should happen is the control will go to my turn procedure, and it will not come out of it. It keeps printing my turn because it is an infinite loop. Let me demonstrate that to you now. Okay, I'll save this program. Sorry, what happened? I'll save this program and compile it first. This is thread 2. Yeah, I'll compile it. It is compiled successfully. Now I'm going to run this. Okay, if you see the result, since I've called my turn procedure first and that has got an infinite loop, so you will only see my turn getting printed and it will not stop because it is an infinite loop. I'll forcefully break it or terminate it. Now I will show you another C program that I've written, which is named as thread 1. Okay, now you have to observe carefully that I'm using the thread library pthread, which allows me to create thread, exit thread, etc. Now I want to run this procedure as a thread. Okay, so what I've done is that uh, so this thread ID is a variable for the thread ID. As I told you that every thread will get an ID. I have not touched this procedure. This will remain as it is. Whereas what I have done, I'm creating a thread inside this process, and this thread should run this procedure, that is my term procedure. Okay, so I'm passing the address of this procedure to this call. I have not made any other change at all here. Okay, so this thread is supposed to print my turn, whereas this procedure is supposed to print your turn. Now can you guess the output of this program? This thread and this procedure, now they run, they're going to run concurrently, because mine is a single processor environment or uniprocessor environment. That means that because Windows is a time shared operating system, this thread will get some time slice, and this procedure P will get some time slice. That is the main function will get some time slice, and thread will also get some time slice. Okay, so when I run this, I see thread running for some time, and I see this main function running for some time, and both this my turn and your turn getting printed, though they are infinite loops. Okay, so let me demonstrate that to you. I'm going to save this and exit out of this program. Now I'll compile this one, thread 1. Since I'm using the thread library, this is the command I'm going to use to compile this program. Now this program is successfully compiled. Now I'm going to run this. Okay, now you look at it carefully. When thread is running, it is printing my turn. When your main function is running, it is printing your turn. Okay, so That's how the thread main, there are two threads here, and both the threads are running concurrently. That is a thread of the main function and another thread which I have created. Okay, so let me stop this. I hope you have understood the concept of threads clearly. I'm going to close this. Sorry, it is not getting terminated. Okay, got terminated. I'm going to close this. Stop running this OS. Okay, with this I would like to conclude this video. To summarize, we have learned why multi-threaded applications are required, or why one has to create multiple threads inside the process, and all the threads are going to share the address space of the process. Okay, and there are a lot of advantages of creating a multi-threaded application. The execution time of the process or an application would drastically come down, and throughput increases, or performance of the system improves if you go for multi-threaded programming. This is about the threads. What I have not discussed much here is how to use the thread libraries that I had listed in one of the slides. POSIX pthreads I have shown how to use, whereas I have not shown you how to use Win32 threads and Java threads. So you may have to work on these and understand how Win32 thread library or Java thread libraries could be used. Thank you.